Hi everyone, my name is Li Yinghan. Me and my teammate Wei Taosun will introduce our project about intelligent auto feeder with IoT technology. Pets, especially cats, are raised in more and more families. An auto feeder becomes a good choice to take care of pets when people are away from home. There are lots of auto cat feeder machines on the market, but we find them to have a similar problem that those machines can only feed cats with fixed amount and fixed period, and thus may cause food waste. To solve this problem, we want to design an auto feeder that can feed cats smartly, allow users to control and monitor the machine, have an IoT app with server and client ends to use remotely. To achieve these goals, we need to complete three major tasks. First, we need to detect remaining amount of food and water. And second, we should be able to add food and water dynamically according to the remaining amount. Third, we should also allow manual feed, and users can receive feedback or see current status of the machine on the mobile app. This flowchart shows three major technical parts. The first part is hardware and signal processing part. We designed the prototype of our auto feeder. The left picture is the overview of the machine, which consists of a food tank, a water tank, and two bowls in the below. The right picture is the structure inside the food tank to let out cat food. We will use load module to detect food amount in the bowl, ultrasonic module to detect food in the big tank. The signals are collected by Arduino and then sent to Raspberry Pi through Bluetooth. The Raspberry Pi will process signals and to detect the remaining amount in the food container. The second and third technical parts are a cloud server and a mobile app. The Raspberry Pi will send information like the remaining amount of food and water to the cloud server. A user can use the mobile app to see the previous record of feeding activity by requesting the data stored in the cloud server. A user can also feed cats manually. Then the mobile app will send an HTTP post to read and write in the cloud server. When the cloud server receives the instruction to feed cats, it will send the information to Raspberry Pi and ask it to add more food.
Currently, most parts of our project has been completed or in progress. Only remain a few specific functions not started yet. And for example, in client side, we have finished the app development and established a stable connection with cloud server. User can use mobile app to manually add food, change the auto feed period or amount. Also, user can use the app to track the machine's recent activities and status, and the server will keep a more detailed log on the cloud. On the machine side, we have finished the design of whole mechanisms, and we have 3D printed the core feeding components as well as the loader module. And the Raspberry Pi can transmit the data instructions between Nano and cloud server by BLE and HTTP connections. In future, first things we need to do is completing the whole machine and make it work. Then we need to add more features like detect the food remaining by ultrasonic module and the water remaining by OpenCV. After that, we will start to do some optimizations, like in current BLE and HTTP connections. All message transmission methods are pooling. It wastes many resources and makes the log filled by many meaningless information. We plan to replace it by BLE notice method and WebSocket. Also for security, currently we use a hard-coded password in app and attach it by JSON in post request to identify user. Since we plan to add camera to capture pictures, so we need more security technicals. Thus, we plan to use password and verification codes to verify user and use token and session to maintain user status. In summary, currently our project already has the basic functionality, but it still needs more convenient features. and improve the performance and security. So that's all materials in our checkpoint presentation. Thank you, everyone.